Hello, so we are going to try to do some questions on mass spectrometry of elements. This is the first question. The mass spectrum for an average sample of a pure element is shown below. So we have a atomic mass as the x-axis and relative abundance in percent on the y-axis. Which of the following is the identity of the element? So when we look at this graph over here, we can see that 184 has the highest relative abundance and somewhat less than 184 is, so if we look at this graph, the average atomic mass would be less than 184, because if we compare 186 and 182 and 183, we have more 182 183 than 186, and when we put in average, that would be the average would lean toward less than 184. That would be the atomic mass. So if we look at the periodic table and find the so let's find the element that we want to have the atomic mass less than 184. So we have W. So this element W, I'm not sure its name, but with this element W, it has an atomic mass of 183.84. So it's approximately to our extent. It's quite similar to our approximation. So I would say W would be the right element for this one. The reason that TA wouldn't work because 180, and we don't have any 180, so that would be too low. Or the closest, the next closest would be RE, but 186.21. But there's nothing that is above 186 that can counterbalance 186 by itself. So 186.21 would be the average of this spectrum, mass spectrum. So I would say B, the element W would be the right choice. There we go. Perfect. For the next question, the mass spectrum for an average sample of a pure element is shown below. Based on the spectrum, which of the following is true about the element? Okay, so if we look at the mass spectrum again, it has the highest relative abundance at atomic mass of 64, but it kind of like slow down. It has a lower relative abundance at 66 and a lower relative abundance at 68. So its relative abundance, its average would be between 64 and 68. That will be a certain thing. It will be between 64 and 68. But it will lean towards 64 more because there's more 64. So let's see what the answer. What would be the right answer for the mass spectrum above. Based on this spectrum, which of the following is true about the element? The element has an average atomic mass of 64 U. That wouldn't be right because you have 68 and 66. So the average would be greater than 64. The most abundant isotope of the element has an atomic mass of 64 U. That looks right, but let's see if there are other answers. In an average sample of the element, less than 20% of the atoms have an atomic mass of 66 U. So in an average sample of the element, the less than 20% of the atoms have an atomic mass of 66 U. It would be right because if we look at 66, it's closer to 30%, so it's not less than 20%. And our D, the element has an average atomic mass between 66 and 68. That would be true because it should be between 64 and 66 because we have 64 and the amount of relative abundance at 64 is greater than 68. So our final answer should be B. There we go. Perfect. Okay. The average atomic mass of lithium, or Li, is 6.94U. Which of the following mass spectra could correspond to an average sample of lithium? Okay, so average atomic mass of lithium is 6.94. So let's look at this. With this spectrum, we have 6, which is the highest, and 7, which is there's 7, but not as high as 6. So it will lean towards 6 more. But we have 6.94, which is, it leans toward 7 a lot. So A wouldn't be right. Let's check B. With B, we have 6 with very low relative abundance, but 7 has a very high relative abundance. So B would be right because it leans towards 7. It's not 7 exactly, it's 6.94 because we have some 6 in there, and it average out so that it will be a little bit less than 7, but it will lean towards 7. So B would be right. Let's check C and D. With C, we have 100% at 7. So the average would be exactly 7, but we have the average atomic mass of lithium is 6.94. So there are some isotopes that has an atomic mass less than 7. So 6 point, so C wouldn't be right, because if C is right, the atomic mass of lithium would be exactly at 7U. With D, we have half and half, 50% at 6 and 50% at 7. So we can calculate this quickly. So the average would be at 6.5. We have the average of 6.94. So D wouldn't be right. So our final answer should be B. Perfect. There we go. Chemical elements that do not exist in nature but can be created in the laboratory are known as synthetic elements. Okay. Flevovium Fl is a synthetic element with an atomic number of 114, was first synthesized in 1998. A hypothetical mass spectrum for a sample of Fl containing 10 atoms is shown below. Okay, that's perfect. Using the information in the spectrum, calculate the average atomic mass of Fl in the sample. Okay, so to calculate the average of anything, we would add up everything. So we would use the same thing in this question. To calculate any type of average, we would add up all the data we have and divide by the total amount, the total quantity. So we have 287.2. We have 287.2 atomic mass unit, and we have 2 of them. So we would times it by 2. And we'll do the same thing with 288.2, and we'll times it by 2. And we would do the same thing with 289.2. But in this case, we would times it by 6 because there's 6 of them, and we would add all of them. So let's do our multiplication first. So 287.2 times 2, and then 288.2 times 2, and then 289.2 times 6. Okay. So if we have a look at this, which you should be able to see it right now, we have 3 multiplication, and that will be corresponding to each of the atomic mass and times it by the quantity or the number of atoms. So now we have all of this. We would want to add them together. When we calculate average, we would want to add everything together. So we have 574.4 plus 576.4 plus 1735.2. And if we put it in to our calculator, the final answer we should have is 2,886. So we have the total, which is 2,886. Let's write it down. 2,886. And now we're going to divide it by the total quantity of atoms. So we have 10 atoms. We have 2 plus 2 plus 6. So 2 plus 2 plus 6 would be 10. And we're going to take 2,886 and divide by 10 to get the average, because we already add up all the quantity for 10 atoms, and now we're going to divide by 10 atoms to get the average of one atom. When we divide like that, we're going to have the average of one atom. So if we're going to do that and put into a calculator 2,886 divided by 10, the answer you should get is 288.6. And that should be our final answer. And we're going to have an answer with 4 significant figures, so 288.6. Perfect. There we go. That's all for this one, and thank you very much.